Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. Today we are going to learn about the soil compaction, and that would be the part 2 of the lecture number 9. In part 2 of the lecture number 9, we will start with the laboratory compaction tests. First one is the standard Proctor test. We will solve a problem related to the standard Proctor test. Then we will discuss about the modified Proctor test and the compaction effort needed to compact that soil. And we will also make a comparison between the standard and modified Proctor test in our today's lecture. Compaction equipments and field compaction tests will be discussed in coming videos. So starting with the stage 1 of the compaction process, the compaction of soil is required in various engineering projects, such as if we are constructing embankment in the field. First, we need to conduct lab compaction tests, which are standard, Proctor test, and modified Proctor test. Why we perform these tests? We need to find out the optimum moisture content, which is the OMC, for achieving the maximum dry density, rho d, or gamma into d, which is the unit weight in the field. Then in the stage 2, compaction equipments, different types of rollers are used to achieve the required dry density or the unit weight. In stage 3, during the compaction process, we perform field compaction tests, which are the rubber balloon method, sand cone method, and nuclear density meter, or they usually call that as densometer as well. Now, why we perform the field compaction tests? They are performed to find out the dry density in the field. We achieved that in the stage 1, and we use various types of compaction equipments to achieve that dry density. Now we need to check whether that dry density which is achieved by the stage 2, how much it's related with the stage 1, and that will give us an idea about the compaction process. So starting with the stage 1 laboratory compaction tests, why we perform laboratory compaction tests? They provide the basis for determining the percent compaction and also give us an idea about how much water content is needed to achieve the required engineering properties or required density or the unit weight. Why we do that? To control the construction process and to assure that the required compaction and water contents are achieved. Now, who proposed the compaction tests? The fundamentals of compaction of fine-grained soils are relatively new, and Ralph R. Proctor in early 1930s developed the principles of compaction. The Proctor test is an impact compaction, which means that a hammer is used and hammer is dropped several times on a soil sample. In a mold, the mass of the hammer, the height of the drop, number of drops, number of layers of the soil, and the volume of the mold are specified. So there are two laboratory compaction tests. One is the standard Proctor test, which is not sufficient for airway and highways. There is another test which is modified Proctor test, which was later adopted by the AASHTO and the ASTM. Starting with the standard Proctor test, ASTM standard is given, where standard effort of 12,400 foot-pound per cubic feet effort is needed to compact that soil. The Proctor compaction test is a laboratory method of experimentally determining the optimal moisture content, OMC, and the maximum dry density, rho d, or gamma d. So based upon the loading or effort, compaction effort needed, we can divide the compaction tests into standard Proctor test, and the another one is the modified Proctor test. However, based upon the particle size distribution, we can divide the compaction laboratory test in three methods: method A, method B, and method C. Now, in method A, the material is used passing number 4 sieve. In method B, material is used passing 3 by 8 inch or 9.5 millimeter sieve. In method C, the material is passed from 3 by 4 inch sieve or 19 millimeter sieve. Now, the method used shall be as indicated in the specification for the material being tested. Based upon the method A, method B, and method C, and if no method is specified, the choice should be based on the material gradation. For example, in case of method A, the material should be passed from number 4 sieve and used if 20% or less by weight of material is retained on number 4 sieve. Mold volume, mold diameter, mold height, and the weight of hammer, height of drop, number of layers, these are 3, number of blows 25, are given in this table. Now, in case of method B is used if more than 20% by weight of material is retained on sieve number 4 and 20% or less by weight of material is retained on 9.5 millimeter sieve. And if you notice here, the mold volume for method A and method B, the mold diameter, mold height, weight of hammer, height of drop, and number of layers and number of blows per layers are same. However, if you see here in the method C, this method is used if more than 20% by weight of material is retained on 9.5 millimeter sieve and less than 30% by weight of material is retained on 19 millimeters sieve. You can also notice the change in the mold volume, mold diameter, and the mold height, weight of hammer, the height of drop, and number of layers. But please notice here that the number of blows per layer are 56 in the case of method C, because larger volume of mold is used in here. The compaction effort used in standard Proctor test in method A, method B, and method C will be the same, but based upon the particle size distribution, method A, method B, and method C will be chosen. If you want to see the manual rammer here, graduated cylinder, mold trowel used to mix the water content and the soil. Mixing pan is there, straight edge to level off the excessive soil which is compacted in this particular mold. This figure also shows the various dimensions of the mold in which the soil is compacted in standard Proctor test. Diameter of the mold, height of the mold, height of drop of the rammer, weight of the rammer is 2.5 kilogram or 5.5 pounds in case of standard Proctor test. What's the procedure? Do not reuse the soil that has been previously compacted in the laboratory. The reuse of previously compacted soil yields a significantly greater maximum dry unit weight. So we need to use fresh soil. We need to mix the water content with the soil so that the particle crushing and particle reorientation won't occur in the pre-used soil. Now we need to thoroughly mix the test fraction, then use a scoop, select the representative soil for each specimen. About 2.3 kilogram of soil should be used for using the method A or method B. But about 5.9 kilogram soil should be used for method C, as we saw in our previous table that larger volume of mold is used in method C. Compact the soil in 3 layers and compact each layer with 25 blows for the 4-inch mold or 56 blows for the 6-inch mold. When using a manual rammer, we need to follow a certain pattern in order to avoid the non-uniformity in the specimen or the soil which is being compacted in the mold. I will show you in coming slides. Once the soil is compacted in 3 layers, we need to remove the collar and the base plate from the mold, and we will calculate the molding water content, moist density, dry density and dry unit weight of each compacted specimen, which will be explained in coming slide. So first we need to determine the weight of the mold, which is W1, and then we will determine the weight of the mold plus the compacted moist soil, that would be W2. We will determine the weight of the compacted moist soil, which means that we need to subtract the weight of the mold, which is W1, from the W2, and the moist unit weight is given using this equation, and that is important. Compaction moisture content, we can take a soil chunk from the soil which is compacted in the mold and we can place it in the oven for 24 hours and we will find out the percentage. And now if you want to find out the dry unit weight, we can use this equation to find out the dry unit weight. So we'll use the information obtained from this equation, which is the moist unit weight and the water content percentage, and we will find out the dry unit weight. Now explaining the blow pattern, when using a 4-inch mold and manual rammer, we need to follow the blow pattern. For example, 1, 2, 3 and 4, then you can go and compact the soil in a clockwise direction, and that was for the 4-inch sieve. Using a 6-inch mold and manual rammer, we need to follow the pattern of 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can continue from the 1 and 2 again. And that blow pattern is for the 6-inch sieve. Now let's solve a simple problem, which is problem number 1. A soil sample is taken from a borrow pit, and that soil is having a specific gravity of soil solids 2.65. The sample was taken to a materials laboratory and tested. Results of standard Proctor test are tabulated below. Weight of soil is given in the column number 1. Moisture content is given in the column number 2. We are asked to find out the optimum moisture content and the maximum dry unit weight. Weight of soil is given in the column number 1 and moisture content is given in the column number 2. If you use these equations, so directly we are given with the weight of soil. Okay, this is the W2 minus W1, and this is water content percentage. So this will be the column number 3 can be obtained using this equation, which is W2 minus W1, 1 by 30th of cubic feet. That is the volume of the mold. And column number 4 can be obtained using this equation, where we are going to use the information of the column number 3 is obtained from this equation. So if we solve this problem, we can obtain the bulk unit weight. This is the column number 3 and this is the column number 4. So bulk unit weight and dry unit weight can be obtained easily using those two equations. Once we obtain various values of the dry unit weight, we can plot these values using Excel, and then we can easily find out the optimum moisture content and the maximum dry unit weight. And the values obtained here for the optimum moisture content will be 15% and the maximum dry unit weight will be 101 pound per cubic feet from that compaction curve. Now for the modified Proctor test, modified compaction effort is needed and is applied, and that is approximately 56,000 foot-pound per cubic feet. Now why we are using a modified version of the Proctor compaction test? The modified Proctor test was developed to represent the heavier compaction than that in the standard Proctor test. The test is used to simulate field conditions where heavy rollers are used. The test was standardized by the AASHTO, and the whole procedure is same as the standard compaction test except the following changes. For example, the rammer used is much heavier, 4.5 kilograms or 10 pounds, as compared to the standard Proctor test. Greater drop is applied comparison to the standard Proctor test. For example, in standard Proctor test that was 12-inch, and in the modified Proctor test this is 18-inch. This is the modified Proctor test. The soil is compacted in 5 layers, and the compactive effort in modified Proctor test is 4.56 times greater than the standard Proctor test. Again, based upon the particle size distribution, method A, method B, and method C, 3 methods are used. So these methods are based upon the particle size distribution, and you can clearly see the mold volumes, diameters, they are same, just based upon the particle size distribution. Method A and method B is chosen. And also, if you see here, method C is also based upon the particle size distribution, but greater mold volume, mold diameter, mold height is same, weight of hammer is same as well, height of drop is same, but number of soil layers, they are also same, but 56 number of blows are used in case of method C, and the mold volume and diameters are different. If you want to make a comparison between the standard Proctor hammer and the modified Proctor hammer, so you can visually see the difference between those two hammers. Now the compaction effort, it is equal to the energy transferred or the work done to an object when a force of 1 Newton acts on that object in the direction of its motion through a distance of 1 meter. So 1 joule is equal to 1 Newton meter. From the elementary physics, we already know that. Now if you want to calculate the energy which is transferred to that particular soil, so we can use the E, which is the energy, number of blows per layer, number of layers, weight of hammer, height of drop of hammer, volume of the mold. So for the standard Proctor test, the energy transferred to that soil in that particular mold, number of blows per layer will be 25, number of layers 3, weight of hammer in pounds 5.5, and height of drop in feet, that would be 12 inches or 1 feet, and 1/30th of the cubic feet is the volume of the mold. So the energy, total energy transferred to the soil would be 12,375 foot-pound per cubic feet. And if you want in other units such as kilonewton meter per cubic meter, or we can approximately write as 600 kilonewton meter per cubic meter. The energy transferred to the soil in case of the modified Proctor test would be number of blows 25, number of layers 5, and weight of hammer 10 pounds. Height of drop would be 18 inches or 1.5 feet. The volume of mold 1/30th of the cubic feet, and you can see that it's 56,250 foot-pound per cubic feet. Now in the field, compactive effort is the number of passes of the roller of a certain type and weight on a given volume of soil. If you want to make a comparison between the standard Proctor test and modified Proctor test, so in standard Proctor test 12 inch in height of drop is used. However, in case of the modified one, 18 inch height of drop is used. The weight of hammer is 5.5 pound and 10 pounds in case of modified one. 3 layers in case of the standard Proctor test, the soil is compacted in 3 layers, and in case of the modified one, 5 layers are needed to compact that soil. Energy transfer, as we calculated in our previous slide, that's approximately 12,375 pound per cubic feet, and energy in case of the modified Proctor test is approximately 4.6 times greater than the standard Proctor test to simulate the higher compacting equipments used in the field. That's all for the today's lecture. We will start with our next video with the compaction equipment which are used in the field to achieve the optimum moisture content and also the maximum dry unit weight and maximum dry density. Thank you very much for watching our videos, and hope to see you in our next lecture. Thank you and assalamu alaikum.